We saw previously how to calculate simple probabilities and simple events. And in this lesson, we will see how to calculate and how to get the probability of two events happening at the same time. Well, a very helpful way to see the outcomes of two events happening at the same time is to present the outcomes using Venn diagrams. So Venn diagrams are very helpful to display sets. We know this already. And sometimes whenever we want to find the probability of two events happening at the same time, using Venn diagrams would be the answer to, would be the key to answer this type of questions. Well, let's see an example to understand what I'm talking about. So imagine I have this example. There are 15 cards and each card has an integer from 1 to 15. So I have cards from 1 to 15. You take a card at random and you need to find the probability that it is a multiple of 3 and a multiple of 12. So I have two events happening at the same time here. Being multiple of 3 and factor of 12. The second thing, I would like to get the probability of picking a card with a number that is multiple of 3 and a factor, not a factor of 12. And the third thing, I need to get the probability of picking a number or a card that is not a multiple of 3 and nor a factor of 12. So a very useful way to understand this problem is to represent the sets first. So I would like to represent the set M, which is multiple of 3, and F, which is factor of 12. Okay, so I will represent this in Venn diagrams. Right. Well, representing it like that, we know that numbers that are multiple of 3 and less than 15, between 15 and between 1 and 15 are 3, 6, 12, 9, and 15. And if we talk about factors of 12, I will have 1, 12, 2, 6, and 3, 4. And as you can see, I have the intersection between the two sets. There are three numbers here, 3, 6, and 12. So I know that there are 3 common elements between M and F. And other numbers are outside the two sets here because they are not multiple of 3 and they are not factors of 12. Now, if I would like to get the probability that the number is multiple of 3 and factor of 12 at the same time, I just need to consider the number of elements in the intersection set. So we know that the intersection set will only have 3 elements, so the probability will be 3 over 15. 15 is the possible cards, the number of possible cards that I can pick from. So 3 over 15 can simplify to 1 over 5, divided by 3 and 3. The upper part and the lower part of this fraction will give you 1 over 5. Now, if I would like to get the second event is getting a number that is multiple of 3, but is not factor of 12. So multiple of 3 and is not factor of 12 is only these two numbers because these 3 are factors of 12. So I know that there is only 2 numbers that are multiple of 3 and not factor of 12. So I just need to write the probability as a fraction 2 over 15. Now, the last one is neither multiple of 3 and no factor of 12. So I just need to consider all the elements that are outside the union of the two sets here. So 1, 2, 3, 4, 5, 6, 7 elements there. So we know that there are 7 numbers outside both sets. So yeah, those are the elements outside both sets. So the probability should be equal to 7 over 15, not 5 over 15, 7 over 15. Right, so this is how to get the probability using Venn diagram. Let's take another example, more fun. So consider I have this group of people, and as you can see here, they have different color of hairs, and some of them are wearing ties. So I would like to see what is the probability of, let's say they are all of them sitting in the same room and I'm in a different room. So what is the probability that one of them will be called at random, okay? And I would like to know what is the probability that the person that I will call at random will be wearing a tie and would have black hair. So yeah, let's see. So this is the event that I'm looking for. It's an intersection of two events. Two events happen at the same time. Wearing a tie, having a black hair. So how to do this? Well, I can represent this using Venn diagram, right? So I can represent it like that. So I just divided people into categories, wearing tie and having black hair. And as you can see here, there are two people that have black hair and wearing a tie. And if they ask you what is the probability of picking a person having a black hair and wearing a tie, it will be 2/9, because overall I have 9 people here. I have 4 and 5, so it's 9 people. If I would like to know what is the probability of picking a person that is not wearing a tie and have a different color for its hair, or his hair or her hair, then I only have 2 people outside the 2 sets here, so it will be 2/9, right? So another way to represent a problem like that is the simplest way, because in calculating probabilities, the only thing that matter is the number of elements in a set. So instead of representing it like that, I just need to write how many elements in each set. So I know that in this region, I only have 2 elements, so I just need to write 2 here. In the intersection, I know that I have only 2 people, so I just write 2. In this part, I have 3, so I just write 3 here. Outside the 2 sets, I have 2 people here, so I have 1 here and 1 here, so I just write it 2. And having a Venn diagram like that is very helpful, because it will get you the answer directly. I know that I just have 2 people that are wearing a tie, but they don't have a black hair. So the probability of picking a person from that group will be 2 over the sum of all these people. So 2 plus 2 plus 3 plus 3, which is 9. So 2 plus 2/9 is the probability of picking a person wearing a tie but doesn't have a black hair. Right. Well, I think after this, you are ready to work on exercises. Feel free to ask questions, and don't forget to send your homework. Thanks for watching. Bye-bye.